Okay, so I am repeating that what is a linked list? So a linked list is a linear data structure. Linear is what we can keep data in a linear format. Okay, like we used to keep in a array. How many are you present? 11 have joined. Okay. Now, I was talking about object. What is an object? Suppose we have a class like class ABC. So for this class, we can create multiple objects. How we used to create object? We can create object like ABC. Object one is equal to new ABC. Now, what this object one will have? This object one will have all the copies of the instance variables present in the class ABC. Yes. Now, in the same way, we can create multiple objects like ABC. Object 2 is equal to new ABC. Okay. Is it visible? Am I audible or still the problem is there? Tell me fast. I'm not irritating a lot. Okay. Each element of a linked list comprises of two things. That is the data and the reference of the next node. Now, by the definitions, you are not able to understand. Don't worry. When we will do the code, it will be more clear. So each element, suppose we have an element of a linked list. This is an element. This is another element of a linked list. This is another element of a linked list. So every element have two things. First, they have the data. Suppose we are storing a number 5. So there is the data. Second, it have the reference of the next node. Means the location of this node, the second node. So this box, every node will have two things. Okay, first the data. Suppose the number that is 1. Then the reference to the next node. Now this is one point. Next, the most powerful feature of a linked list is that it is of variable size. Now, unlike the array, okay, unlike array, we can increase the size of a linked list at runtime according to our need. So that we will see when we do the code again. Now, just consider this figure. This is what? This is a small train. Now, what are the properties of the train? Now, if I'm explaining this train right now, because when I will explain linked list, it is extremely similar to a train only. Now, the some properties are how to declare a reference. What is a node? So a node is nothing but an element of a linked list. Okay, when I will create a node, then you will understand this. Okay, means suppose like in array we have element like how we have elements. We have elements like this. Every element is denoted by a of 0, a of 1 or a of I. In the same way, a node is one particular element of the linked list, and every particular node or every particular element has two things. First, it has the data which we are storing. Second, it has the reference to the next node. Okay. Now, how to declare the reference? When we will see the code, then we can understand that. Now, in this train, first is that it always starts from an engine. Okay. So, a train always starts from an engine. Next, what we have a property as the guard room will be always at the end. So, this is a guard room. You can see there is a guard room that is always at the end. And all components are joined by a coupler. You can see a small thing here. This is known as nothing but coupler. This is responsible for joining two compartments. And every compartment have a space for passengers. So as we have space for data in a linked list, in the same way, every compartment will have some space to store some passengers. And all compartments are independent. Suppose if you are removing this compartment from here, detaching it from here, and you are connecting from this compartment to this compartment. Now still this train will work perfectly. So every compartment is individual. Now if you want to add one compartment here, you will add one coupler here, and include one compartment in between. So every compartment is independent. So we can add and remove from middle also. So this facility is not available in what? In the array. Now in array, if we want to add one element in the between, but our array is filled, suppose 1, 2, 3, 4. If you want to add something here, so we have to shift this 4 here and this 3 here, then we can add elements in between. But here we can just add an element in order of one time complexity. So here we have to shift the elements. So what will be the time complexity of adding in between? That is nothing but order of n. But here we can perform that in order of 1. So we will see order of 1 how when we will see the coding. Now next property is that from one compartment we can traverse to all other compartments. So you can see these all compartments are connected in actual train. You can just run from one compartment or walk from one compartment to the end of other compartment. Okay, so that is the thing. Now what I am going to do for denoting one node. Okay, first let us compare these details with our actual linked list. So we have nodes in a linked list. Okay, so one compartment can be is equivalent to a one node of a linked list. Now we have told that. So I am just explaining the diagrammatic explanation. Then we will understand it while coding. So every node has what two things. First is for data. So suppose we are having a data as one. Next we have. Okay, let me draw it first. Okay, now there is a head which is pointing to the first node. Okay, so every whenever we try to traverse a linked list, what we'll do, we'll start from head only. Now in the same way, you can see we have an engine, a train starting with an engine always. Now we have couplers. You can see in the train we have couplers. In the same way, we have reference. So the second part of a node have the reference of the next node. Okay, so you can see here it is also having the reference of the next node, and at the last node is having no reference, so it is pointing to null. Now what next we can compare? You can see null is always the last at the last point. In the same way we have this guard box here. Now in a linked list also we can insert a node in between. So every node is independent. What we can do? We can detach this node. We can detach this reference. Change reference of, suppose this is a new node and it has some element like 4. Now we can change this reference to this node and this reference to this node. Now you can see it has been attached in between. Now in the same way, if you want to delete this node, the 3 node, what you can do, you can remove this reference from here and move it to the next node or null. Okay, so this is how our linked list looks like. Okay, it is a practical explanation. Now let us see some more things. Now we have different types of linked list. So first we have single linked list. So just now what we saw is a single linked list. Just now what we saw is a single linked list, which is starting from head, have some elements and ending at tail. Not tail, ending at lastly pointing to null. We are going to discuss all this linked list in one classes. So today we are going to just cover single linked list. I don't know if we can cover it or not because we have very less time. Still let us see. So this is a single linked list. It is a linear data structure. Its first node is pointed by head and last node is pointing to null. Now what is a circular linked list? Circular linked list is what? If we remove this null and our last node is pointing to the first node. So you can see it is a circular structure. If you start iterating it, it will get repeated and repeated. Okay, after the third it will again come to 1. So that is a circular linked list. Now what is a double linked list and what is a circular double linked list? We will discuss later when we will move to that part. So let us start with the first linked list, that is a single linked list. Yes, I am coming to that first, don't worry. So single linked list, in a single linked list, each node in the list stores the data of the node. Now the data type we can define accordingly of the data. Okay, this node has two things. First is the data part, and other is the reference part. So this will be of the class type node. So this will be the data structure for this reference part, and this data type we can define accordingly. Like for array, which we define. If you want int type, so you can define int in the same way. So in a single linked list, each node in the list stores the data of the node and the reference to the next node. Is this point clear or not? Means every node will have two things. Okay, they must have two things. First is the data, second is the reference to the next node. Now nodes does not store the reference of the previous node. Yes, this point is important. Suppose we have two nodes here. This is first node, this is second node. We have a data 1 here, we have a data 2 here. Now this is pointing to this node. Okay, suppose this is the head pointing to this node and this node is pointing to null. Now we don't have a reverse pointer. Okay, we can iterate from this pointer head to null, but we cannot traverse backwards. Okay, we cannot come from this to this because there is no reference at all. In another way, I can say, when we'll do the coding, you will understand that. Okay, don't worry. Just understand the logic first. I am trying to show you the logic. So why we cannot traverse back? Because this D2 or the node 2 don't know that who is the node previous to it, because there is no reference backward direction. But D1 knows that who is the node next to it. Are you getting this point or not? Tell me yes or no. Yes, okay. So some operations are there. So when we will do the coding, we will one by one understand all the operations. So first operation is creation of the linked list. So what I am going to do, I am parallelly going to code that thing also. Okay, I am going to code that thing with along the operations. So first let me explain how we create a single linked list. So suppose we have a class node. Now why I am creating this class node? Because whenever we will create a new node, we want that it should have two things. First, a memory for the data type. Second, a memory for the reference. Now, so what should I mention here? Now suppose we are just practicing integer type linked list only. We can create multiple different data type of linked list, but just now consider integer, we are creating an integer type linked list. So what should be mentioned in the class? So when I create an object, we get these two things. First, we need a data. So we can create a variable int data, yes or no. Now this will make sure that when we create an object of the node class like this, node n is equal to new node. So from n we can access a copy of data. Okay. Now next thing is that we need a reference. So we can store the reference of the next node. Now next node will be of which type? So it will be of node type only, no? It will be of node type. So we can use this node as the data type. So yes, what we are going to do, we are going to create a variable with the name as next, and its data type will be node. Making sense or not? Tell me, is it making sense? Okay, so now we are good to go. Now I want to do something like, when we create the object of the node, at that point only I can store the value. Okay, so suppose I am creating an object of node class, what will happen? A memory block will be allocated. Okay, suppose I am writing this statement, node n is equal to new node, what will happen? The n will be pointing to this memory block, and it will be having what? It will be having two memory locations. First will be for data, and next will be of the variable next. But it will not having any value. It will not having any value. Okay, first we will see that when we will do the code. Keep patience, everyone. You are asking next questions. Keep patience. Everything will be clear. Okay. So, yes, where was I? Okay, so this memory location is created, but it is empty. You can see nothing is stored now. Now, what I want to do, when I create the object of this node class, at that point only I want to store a value. So, what can I do? Can you tell me? Can you tell me what can I do? If I create an object, yes, correct. Jasmeet is very much correct. We can create a constructor. Now, what is a constructor? Constructor is nothing but a function only with the name same as the class name. If you don't know constructor, you can just study it as a part of core Java. Now, what happens with the constructor? I will tell you. Okay. Yes, everyone is correct. Everyone is correct. I am going to accept a data from at the time of creation of object. So, constructor is called when we create an object. I hope you all know this. So this data, I want to store it in this data. Okay, let me name it as another. Okay, let me name it as D. Otherwise, I have used this keyword. So I am naming this as D. So when the data is passed as in the constructor, what next I want to do? I want to store it in this data. So data is equal to D. This will do what? This will store the value which we have passed in the constructor at this location. Suppose we are doing node n is equal to new node 10. So this is the actual data which we have passed. Now this n is pointing to the node to which n is pointing. It will store this value as 10. Now currently this node is not connected to the linked list. Okay, it is just a node. It is not connected to the linked list. So what next we can do? We have to keep this as null only. So next thing I am going to do here, that I am keeping this next as null. Just a second. Is the electricity cut in my area? So let us code this thing. Yes, first we can do that also. If we keep the name, why next is null. See, currently we are just creating a particular node. We are not attaching it to the linked list. Suppose this is our linked list, like head, we have some nodes here. Okay, we have some nodes here. So we are not attaching it to the linked list. So that's why this point we are just keeping it as null. When we will connect it to the linked list, then what we'll do, suppose we have to insert it here. So we will change this reference to pointing to this node. Then we will update this null later to pointing to this node. So for now we are keeping it as null. For that we have to pass next node. No, there is no need to pass next node in the constructor. You can see we don't have to pass any value. Okay, we are just storing the data. This null, we know that it will always be null. Okay, now let me code it so it will be clear, otherwise it will be confusing. Now I am creating a class. Okay, I have created a package with the name as linked list. I am creating a class with the name as single linked list. So this is my class. Now what next I am going to do, I am creating the class node. So this is the node class which I was talking about. Now in this class I am going to create those things which we have just discussed. That is the data variable, and next is the next variable. So this is done. Now what we need to create a constructor. So for that I am creating a constructor here which will accept the data. So this is done, and inside its body, yes, it's a nested class. Now why I am creating it as a nested class, because if I keep it outside and when we will later do the other linked list like double linked list, so then we will have a problem. Okay, it will collide with this node. So that's why I'm keeping it is inside. You can also keep it outside. There is no issue in that, but it will keep the code compact. Okay, so that's why I'm doing it like this. Now we are assigning data as B, and we are assigning next as null. This part is done. Now what we need to do next? Just a second. Now one more thing we need to create. We need to create a head reference. Okay, so this was the head. You can see we have something known as head. Okay, we want to keep it as null initially, and later when we will store some linked list, when we will add some nodes, we will update that head accordingly. So initially I am creating a head which is again of node type, because it is going to keep the reference of a node. Okay, so this is not a object. I am creating it outside this class. So I am creating, let me comment it here. This is the head reference, and I am creating it as static. Why? Because it is not inside any function, it is just inside the class. So that's why I am writing it as static. Its data type is node, because it is going to keep the reference of a node. Okay, so that's why, and its name, let it be head. So this is done. So till now everything looks good. At the last, okay, we will create our, okay, let us create the main block. Okay, we will come later to the main block when we will create all the functions, then we will try the code. Now next, what is the thing which we can do? Now next operation we are going to create is insertion. Now insertion can be, keep patience, we will see that we are just started insertion. So insertion is the same thing. How we are initializing the reference. Okay, so insertion can be done in 3 ways. First, we can insert either at the front of the linked list. Suppose we have a head, we have our first node, we have our second node, and this is pointing to null. Now either you can insert at the front of the linked list, that is nothing but here. If you want to insert element, you can remove this null. This will be pointing to a new node, and that will be pointing to null again. So that is at front. Second thing is that you can add an element at the back. At the back means at the end. How? suppose again if this is head, these are the nodes, this is pointing to null. We want to add something here. So we will change, suppose we have created a new node. Okay, how we create this node? We'll create the object of the node and we'll pass the data in the constructor. So that we know now. Then we will update this head to the new node which we have created, and we will update the next of the new node, which is this reference, to the head, to the point where previously head was pointing. So this is how we can insert at the back of the linked list. Now third thing is that we can insert at the middle. Okay, so how we can insert at the middle? Suppose we are having head, then we have node, then we have a node, then we have a node, then we have a null. Now this normally looks like this thing. Okay, every node has two compartments. Suppose we have created a new node. This is the new node. This is storing 1, 2, 3. Suppose this is storing 4. Now initially when we create the new node, what this is having the data, but this is pointing to null according to our code. This will be pointing to null. Now what we can do, we can if we want to insert in middle, so we have to we have to keep a value also. Suppose we want to insert it after 2. So we will traverse the linked list from head. We will go to head.next. Is the data matching to 2? No, we are going to next element. Is the data matching to 2? Yes. So what we are going to do, we are going to change the reference of this 2 to next of this second node to this node, the new node, and the next of the new node to the next node of the second node. So first let us see this, then we will see this, then we will see this. Okay, so we are going to create 3 functions. First for insertion at front, then for insertion at back, then for insertion at middle. Now let me see the time. It's already 7. So 7:10 I will finish it. So what I'm going to do, I'm going to create a function. Let me name it as insertion at front. Now I'm going to create a function that will be public void, and I'm naming it as push. Okay, so what I'm going to do, I'm going to name the, okay, let us take another name. Push is for the operation in stack. So I'm naming it as insertion at front only. Okay, so insert front. Let this I be small according to the camel case concept. Okay, now what I have to do, what thing I have to pass in this function? The data which you want to insert. So I'm creating it as in data. So this is the function body. Now first thing what we have to do, before inserting the node, first we have to create that node. Yes or no? How we can create that node? We can just create the object. How we can create the object? Let the name of this object be new node. Okay, so this is the new node, and we know that when we'll create the object and pass this data in the constructor, our new node will be created, but it will be pointing to null. So we will just write new node and in data. We are passing the data in the constructor. Now is this making sense? This is how our new node will be created, but it is not inserted till now. Give me a yes or no again please. Now I have told you that when we will create the object of this class node, what will happen? A reference will be created which will have a copy of these 2 variables. For every object, a new copy of these 2 variables will be created. This is the basic concepts of object-oriented programming. And when we create an object, you can see this is, where is it? Yes, this part is object reference creation. Okay, here we are not creating an object. You can see we are creating node head. This is just an object reference. We can hold any object. Object is created when we use the new keyword. Now this is the object which is created, and the new node is pointing to this object. Now what we are going to do, we are passing the data which we have passed in the function. So using that data we can create a new node. So this will be calling this constructor will be called, and a node will be created which is having the data and it is pointing to null. Nothing but let me tell you how it will look. It will be just a fresh node. Okay, it will look like this. Suppose the data has been passed D and this will be pointing to null. So this much we have done. But what we have to we want to do, we have to insert this node at the front of the linked list. Okay, now I am telling you front. Front means this part. So this is front. Okay, this is front means at the head, and back means at the end. So this is back. So I am going to insert at the front. Now what I can do? Let me first explain you only. Then I will code that. So first, what I can do? I can do that. This is the new node. Okay, this is the new node. Its name is new node. Now I want to suppose we have a head, then we have a linked list, then we have null. Now we want to insert it here. Okay, we want to insert it here. So what is the code which is to be written for changing this null reference to the first node of the head, to the first node where head is pointing? So we can write new node dot next. So this is which next variable? This is the next variable which is present in this node. Okay, this next. Now we are updating it to, yes, correct. So we are updating it to head. Making sense or not? So this will do what? This will be pointing where head is pointing. So we all know that head was just an object reference. Now where head is pointing, this node will be also pointing. But one thing is still left. This head is also pointing to this node only. Now we have to change this head reference to the new node. Yes. Now we can write. Okay, so people are giving the correct answer. So we can do that head is equal to new node. So this is how head will be pointing to new node. Is this clear? I hope this is clear. So now if head is equal to null, okay, so if head is equal to null, what we can do? We can just do head is equal to new node. So then there is no need of the first statement. Now still this part is correct. Can you tell me why? Okay, let me erase some parts. Now even the first head is pointing to null. Let me write here. Now even we have a head and this is pointing to null. Still we follow these steps. It will be correct. Now suppose head is pointing to null. This is the new node which we have created. It is also pointing to null. Now first new node dot next is head. It means this reference is changing to where head is pointing. So again it will point to head only, na? Because head is pointing to null. This is having the data. Then we are changing head is equal to new node. So we are changing this reference to the new node reference. So now this will look like what? This will look like that head is pointing to the new node with the data D, and this is pointing to, you can see, null. Okay, so this will work only. We don't have to create another statement like that if head is equal to null. Okay. Are you getting, Jasmeet, why we don't need this condition if head is equal to null or not? So I am coding this here. So the two statements that new node dot next is equal to head, and later we are updating the head to the new node. This is done. So this will help us to insert at the front. Okay, insert at the front of the linked list. So let us check that out. Okay, so I am creating the scanner object. Just a second. So can we declare head to any integer value? See, head is a object reference. Okay, it is an object reference which can hold only node type of object. It can't hold any integer value. You can see the data type. Node is acting as a data type. Okay, you can see here in the line number 20, it is of the data type node. It can't hold any integer value. It can hold any object reference of node class type. Why? Because its data type is node. Okay, just a second. Now I am creating the scanner class first. So whenever we need to take the input, we will use the its object. This is done. Why head is static? See, if I remove the static keyword from here, okay, I thought that it would be showing here error. Okay, it's fine. Then let us keep it like this only. If I move it up, okay, let it be like this. Later we will see if any problem occurs, we can change it to static. Now after scanner, I am going to create an object. You can see because this function, the insert front, is not a static function. So we can call it only through the object of the single linked list class. So I am creating an object of the single linked list class. Let it be li is equal to new single linked list. Okay, this is done. Now what we can do, we can insert some values. So I am doing li dot insert front. Let us enter 12. Then li dot insert front. Let us enter 13. Not till now we cannot see those values. It will be just inserted, but we haven't written any function for iterating those values. So first let us write the function to iterate the linked list also. So I am writing here one more function. Okay, head can be initialized with next as both are from both classes. Okay, now I am writing a function to traverse the linked list. Okay, so I am naming it as public void and print list. Okay, this is the name which I am using, print list. Now we don't have to pass anything because we just want to iterate the array. We also have the head reference only. So what we can do now, if I iterate using head, see, let me show you what I want to do. I am showing how to traverse a single linked list. So let me draw a linked list first. We have a head, then we have the first node which is storing 1, then we have the second node which is storing 2, then we have the third node which is storing 3, then lastly it is pointing to null. Now we have this head, and what we can do that while this head, or we can say head, is not null, we can update it. Okay, we can do that. We can print the value, that system.out.print head dot data, and we can do update head is equal to head dot next. Now in every step what it will do, it will print this data and this head will change, this reference will change to head dot next. Now again this will print the data and its reference will change to head dot, okay, this reference will change to head dot next. Now one problem is here with this thing. Okay, one problem is here with this thing, that we can't change this head. If we change this head, later we cannot access this variable. So for that what we can do, we can create a copy of this head. So how we can create a copy of this head? So we can create a new node. Okay, we can create a new node reference. Let me use another color. So this condition, this code is wrong. Why? We cannot change the reference of the head, because if we remove this head reference, now this there is no object reference which is pointing to this node. So this node is lost. So we don't want to lose the connection. So for that we are going to create a temporary node. Okay, suppose node temp. Now in this we are going to store head. Now this will do what? This will create a temp similarly like head. This is object reference which is also pointing to the first node. Now using this we can iterate. How we can iterate? We can say that while this temp is not pointing to null, what we'll do, we will just print what is present in the data of that node, that is temp.data, and along with that we are going to update temp with temp.next. Are you getting this? Is this code clear? How we can iterate the linked list? Head not equal to null or head dot next not equal to null. Okay, see, head, initially we are having head at what? This node. So it will start from this node only, and next, then when it will go to temp.next, okay, then it will reach to this node, then it will go to temp.next, then it will reach this node, and at one point it will reach null also. So that's why we are comparing temp is equal to null, not temp.next is equal to null. Okay. Okay, great. So let us put this together. So I am just doing that same thing. We are creating a temp node in which we are copying the reference of the head. Then I'm using a while loop where I'm checking that this temp doesn't reach as null. When it will reach null, or what it will do, the while loop will stop. So until this statement is true, we are printing the element present in the node head dot data. So not head dot data, that is nothing but temp dot data. Next, I am updating temp as temp dot next. So this is done. Why temp not equal to null? See, let me do the dry run for you. Then we will come back to this. Okay, one more thing let me add here. Let me add a line changer. After printing all the elements, it will change the line. Okay. I am explaining that to you. Okay. So see, first what will happen? This temp is pointing to where head is pointing. Making sense? This temp is pointing at this node. Head is also pointing at this node. Now it is checking. Is temp? Sorry, it is not equal to. Is temp not equal to null? So is it true? Temp is not equal to null. Yes, temp is not equal to null. It is pointing at a particular node. So condition is true, and it will print the data associated with temp. That is nothing but 1. So 1 will be printed on the output screen. Now temp is updated to temp.next. What is temp.next? This reference is removed, and now temp is pointing to the next element. Now we are checking, is it pointing to null? No, it is not pointing to null. So we are again printing the data associated with it. So it will print 2. Now again we are updating temp to temp.next. Now is it pointing to null? No, it is not pointing to null. So we can print the data, that is 3. Now we are updating this to temp.next. So it will point to null. Now is it pointing to null? Yes, it is pointing to null. So we are stopping the iteration. Is it clear, Sunil? So this is how we can iterate. Now let us check if it is working or not. So we are inserting some elements. Okay, we are inserting some elements, and see, these elements are inserted at front. Let it be 12, 13, and 14. Now I am printing. Okay, I am printing the list. Tell me what will be the output. Will it be 12, 13, 14 or 14, 13, 12? Just think. Then I will run it. Will it be 12, 13, 14 or 14, 13, 12? It is inserting at front. Let everyone answer. Okay, then I will tell. Let me check how many of you are here. Okay, I can see 24 students. Where is the code? Some are telling 12, 13, 14. Some are telling 14, 13, 12. Let us wait for a few more comments. Okay, so now I'm keeping the answer in front of you. See, I'm running this code and it is printing. Okay, it is printing 14, 13 and 12. Now why this is happening? Are you getting why this is happening? So let me explain it to you. So we have inserted how? We have inserted, let me erase all things. First we have inserted 14 that was at the front. So this is our head. This is initially pointing to null. We are inserting 14 here. Then how it is pointing? It is head. This is pointing to 14. This node is pointing to null. Again we are inserting what we inserted first? 12. No? Okay. So 12. Let me check. Yes, we inserted 12, then 13, then 14. Where is this line? Okay. So this was 12. So this is 12. Now we inserted 13, but it is inserted at the front. So head, then we have here it is inserted. Okay, so it is changed to 13, and then this 13 is pointing to 12, and this is pointing to null. Again we inserted 14. So this is again pointing at the front, that is at the head. So this is changed to 14. This is changed to 13. Not changed. You can see it is inserted at this point. Okay, it's inserted at this point. This is changed to 12, and this is nothing but null. Now we are iterating from head, so it is printing 14, 13 and 12 respectively. Making sense? So those who are telling 14, 13 and 12 are very much correct. Now what can be the next operation we can perform? Okay, so we have seen how we can iterate, how we can insert element at the front. Now let us see how we can insert element at the back. Before that, just check this code once. If you have a doubt, tell me. Okay, then we will do the next thing. Okay, I think let us keep the today's class till here only. I am giving the time to discuss the doubts as I was told. Okay, I was told to take only 30 minutes class, but due to technical issue, I have taken a more real class. Is the code fine? Anyone, any confusion, just tell me. Okay, this is insert at front and this is the, these are the two functions. I wanted to take today's class till 8 p.m. but since I am told by Pratik sir to end the class in 30 minutes, that's why I ended. Okay, from Monday we will see what happens, what you all decide. Why there are two classes? Where? Okay, in the live class session. Yes, please, if you understand what was the problem, if you understand what is the mistake, just talk to Pratik sir. It will be helpful for both of us, for me also, for you also. Okay. So yes, let us end this class now. So this code I am not pushing to the GitHub repository now because many things are left. Later what I will do, I will use a switch case for all the operations and we can do insertion deletion at runtime. So those things when I will complete this code, I think on Monday or Tuesday, then I will push it to the GitHub repository. So yes, any more thing from any previous class? Someone was asking me some question on, I can't continue Sunil. I am not allowed, I will be scolded then. Okay, someone was asking some question on WhatsApp. I told him or her to that I will check that later. Okay, let me see if the question is available on WhatsApp. Okay, yes, this was the code. Okay, the code was something like this. And she was asking that what will be the time complexity. So for int I is equal to 0, I less than 5, I plus plus. So at some point I am adding the time complexity, at some point I am multiplying the time complexity. So what is the reason behind that? So int j is equal to 0, j is less than I, j plus plus. Then I am doing that system.out.print star. Those who know the time complexity, just tell me quickly what will be the time complexity for this. Then I am changing the line. This is the code. N square, everyone agrees. Now the question is that when I will multiply the time complexity and when I will add. So you can see when this for loop would have been outside. Okay, when this for loop would have been here, so then the complexity of this and this would have been added. So this would be an order of 1, this would have been order of 1. So then we can add it. But since it is inside, so now we are multiplying the time complexity of the outer loop with whatever is inside. You can see we have this as order of n, we have this as order of 1. Now since this part is again inside this for loop, what we will do? We will add them or multiply them. So we will multiply them. But this part is what? This is outside of the inner for loop. Just see clearly. This is outside of the inner for loop. So what we will do? We will add order of 1 to it. Now this whole thing is inside the outer for loop. So this whole thing will be multiplied with big O of n. Now how this will look? This will look like for the outer while loop for loop we are having big O of n, which is multiplied with big O of n for the internal for loop. Now for internal for loop, the statements inside are or big of 1. So we are multiplying it with that because this statement is inside, not it is not outside that for loop. Now we have this system.out.println outside of the internal for loop. Okay, so now we can add it. So this is how our time complexity, when you solve this, it will become nothing but big of n square. Is it clear? Whoever asked this to me on WhatsApp. Okay, let me check the name. What was the name? Anpurna, yes. Is it clear, Anpurna? Okay, great. Any more? Anyone? Any confusion from any classes? If n is initialized with 5, where is n? See, this is big O notation. Okay, there is no point of initializing it. We are just checking the worst case scenario. Then it would be big of n or big of 5. There is no point of initializing. You can see in this code, do we have any n thing here? Okay, we don't have any n variable. Why is that we have to declare head node in the node class itself? Because practically, when the at which point you can tell me at which point the linked list is being created? Is it created here? No, it is created when you are creating the object of this single linked list class. So it is mandatory when you create this object. So there should be a one copy of the head node. Okay, one copy of the head node. That's why we are having this node here. Okay, as the instance variable of the single linked list class. Instead of n, yes, that is correct, Naveen. That is correct. Then it will become a constant. But when we talk about n, we always think about large number. Okay, we 10,000, 1 trillion, 1 billion type of numbers. Okay, when you are considering numbers like 10, 20, that will be, you can say big of n, big of 100 is nothing but constant. So I'm ending this class. Any more doubts? I'm waiting for you all. Now don't tell in the group that sir is not giving us time to ask doubt. Okay. Otherwise problem will be created for me. Sir, print list function. Which print list function? Okay, here. So see, initially if I use the temp, if I use the head node for iterating, that will change my head reference. Later I cannot use the linked list, it is destroyed. So I am copying the head reference in temp and using that temp to iterate. I will keep changing temp to temp.next until I reach the last node. And how can I identify the last node? Because the last node is pointing to null, so it would be null. And every time you can see temp is a node, you can say the data type of temp is node. So you can see when we put dot here, two variables I can access. I can access the data or I can access the next. But I want to print the data, that's why I'm printing the data. Clear, Pranali? I've also shown the dry run. I've also shown the dry run. You can check the recording later. Or if you want me to repeat, I can repeat. So those who have doubt, you can stay and ask. If those who don't have a doubt, can leave. So I didn't wanted the class to be like this. I wanted to do more things, but let us see what happens from Monday. Okay. So thank you for listening with so much patience, guys. Meet you in the next class. That is not in my hand, Salil. Just talk to sir. I think he has stopped the conversations on WhatsApp. Just check if you can send messages on the application, on the group of application chat group. How 14, 13, 12 is printed. Okay. So I'm explaining this. Those who know can leave. Those who want to see can stay. So I have just now shown only one technique. Okay, one technique of insertion. We can insert at front, back, and middle. So I'm inserting at front. Front means what? We have a list like this. This is head. This is pointing to a node. Suppose this is 12. This is pointing to a node. Okay, this is 12. This is the reference position. This is having 13, this is pointing to null. Suppose we have already created a linked list. Now at front means at the point where head is pointing. So suppose first step is what we are creating a node. Suppose we are creating a node as, suppose these are different data. Okay, this is not that question. I will come to that question later. First understand what is instruction at front. So I will, if this is storing suppose 28. Now I will change this head and this head will point to this 28 and I will change this reference to here. Now it will look like what? When I will iterate it, it will print 28, 12 and 13. Now what the question, in that question I did what? In that question, just wait, I will finish this out, then I will move to the next one. In that question what I did, I inserted, let me show you the code. Yes, I inserted 12, 13, then 14. So initially the head was pointing to null. Now I created a node 13. So this is the 13th node, it is pointing to nowhere. Now this head is pointing to here and this is pointing to null. So this is looking like what? This is looking like head, then we are having 13, then we are having null. Now next we inserted, sorry, first we inserted 12, no, okay, sorry, my bad. So first we inserted 12, so this is 12. Now what we did next? We inserted 13. So 13 will come where? At the head, where head is pointing. So suppose this was the new node created for 13. So this reference is updated to this node and this reference is updated to this node. So this will look like what? This will look like head. Then you can see 13 has came at the beginning. Then we can see 12. Then that is pointing to null. Again you created a new node that was 14. So 14 is pointing to this again and head is pointing to this. This reference is removed. So it is looking like what? 14. Now you will iterate from head to null. What you will get? You will get 14 first, then 13, then 12. I hope it is clear now. Naveen is telling that in previous question of complexity you did answer order of answer. Why not it should be 5n? Because first you can say 5n. Okay, you can see 5n. Normally this question should be, I think when I remove that, the loop should be written like this. Okay, for int I is equal to 0, I should be less than 5. I should write like this. I have written like 5 because in the notes it was written like 5. Okay, any more doubt? I am waiting. I am waiting. If you get both options, you won't get. Okay, you won't get that option. Whenever a question is framed, it is framed in such a manner that even if you apply different logics also, you will land up upon the same option. Any other question from any class? Recursion class. So how many classes we had? We had, I think, 4 classes. Yes, we have done introduction, recursion, runtime analysis. Today we are array also done. Today we are discussing linked list. Okay, so those who have no doubt can leave the class. When I will see 0 students, I can understand that no one needs a doubt. No one have a doubt. Okay. So class has ended. You can leave. Thank you, everyone. I will give that in the what I can say in the announcement section. You can check that, Sunil. So when we'll complete the linked list, I will give the link where you can practice more questions on linked list. After the array, if you have checked the announcement section, I have given you that from where you can study questions for array. I can't help with that, Vishwajit, if you have just joined the class. The class has ended. We are just discussing doubts from previous classes. Why not? Pujita, leave that question. It should be n. I know that that is also correct. Okay, but we never express as constants. If we express big O of 5 square, it is nothing but big O of 1 only. That is negligible big O of n. So normally we will see that if there is a loop, from 0 to some particular value, we'll take it as big of n. Big of n, yes, we'll consider it as n.